This video provides a short introduction to scripting languages. The goal of scripting languages is to allow a programmer to accomplish specific tasks quickly without a concern for machine efficiency. Hence, the emphasis is on programmer efficiency. Traditional compiled languages emphasize machine efficiency at the expense of programmer efficiency. Also, scripting languages generally are not meant to be general purpose, although a few, like Python, have been designed that way. Typically, scripting languages aim to fill a specific niche. For example, Perl was designed as a data extraction and report generation language. PHP was designed as a server-side scripting language for serving websites. JavaScript was designed as a client-side scripting language for interacting with the browser. TickleTK, not so often used anymore, but originally was designed to be used with VLSI design tools. So scripting languages often are designed with a specific niche market in mind. So what are some of the characteristics of scripting languages that set them apart from your normal compiled languages? First, it's economy of expression. This is the overarching goal of scripting languages, is allow the programmer to succinctly specify a programming task in as few lines as possible. And the way they accomplish that is with the remaining characteristics. First of all, many scripting languages do not require you to declare variables. Now, as you get into larger scripts, you often do declare your variables as a way of performing some checking, allowing the scripting language to perform some checking to make sure that if you have a typo with a variable, that you don't inadvertently introduce a new variable. So for example, if I have a variable named Brad, and I inadvertently have a typo and spell it as Bard, B-A-R-D. If I declare a variable, it makes it easy to detect the fact that Bard is undeclared. If I don't have a variable declaration, then Bard is simply added as a new variable. However, when you have small scripts, not having to declare variables saves time. Allows you to quickly set something up and experiment with it. Next characteristic is flexible dynamic typing. So we don't require variables to be associated with a fixed type as in a compiled language. The type of a variable can vary and depends on the value currently assigned to it. One place this is very convenient is in graphical user interfaces, where sometimes when we display a label on a button, we use an icon, and sometimes we use a text label. So in this case, a variable named label would sometimes need to have a value of an icon, and sometimes it would need to have the value of a text string. The next thing is that scripting languages typically provide easy access to system facilities. So for example, Perl has an easy way to get to run to change directories, to access file systems, to even escape to the underlying system to run some kind of shell script. So the scripting language, though, makes this access to system facilities be platform independent. So in Perl, it runs on Linux platforms, it runs on Windows, and it runs on Mac OS, but it doesn't use ls as the way, which is the Unix command for listing the contents of a directory. Instead, it uses dir to list the contents of a directory, and this command works across all platforms. So each scripting language that provides access to system facilities actually devises its own commands for accessing the system facilities, and then those get mapped to whatever system commands are used on the specific platform on which that scripting language is currently running. Next up is sophisticated string manipulation, and this is typically accomplished using regular expressions. Regular expressions were popularized by Perl. We'll be talking about them in the Perl lecture. But regular expressions allow us to specify patterns that we're looking for in data, or to specify patterns that user input should satisfy. So for example, we might be looking for Social Security numbers. Social Security numbers have a characteristic of 3 numbers, a dash, 2 numbers, a dash, and 4 numbers. And so we could specify that's the pattern we're searching for and have our scripting language extract, or our program extract, all numbers or all text strings that match that pattern. And then the last thing is built-in high-level data types. And the 2 most commonly provided built-in data types are lists and hash tables, which you'll often hear referred to as associative arrays. When we say built-in, that means that they are native data types and have their own set of operations associated with them. The syntax varies from language to language, but almost all scripting languages support lists and hash tables as built-in data types. Now, they're less efficient than the compiled versions that you use in, say, the standard template library in C++, but their syntactic notation makes them much easier to use, much more programmer-friendly. So those are the main characteristics of scripting languages that set them apart from compiled languages. And actually there's one other important item that I have not put down here, but which I will now add, and that's that they are interpreted rather than compiled. So that means that their statements are interpreted at runtime rather than being compiled into machine code and then run on a native platform. That often makes them much slower than comparable compiled code, up to 10 times slower. But the advantage of an interpreter is that you can immediately run the code when you make a change to the script rather than having to recompile it. It also often means that you don't have to actually terminate the program when it's being run. If you find a bug, you can sometimes patch the bug on the fly by simply changing the appropriate function, reloading that function, and then continuing your execution. It also means you can perform what's called rapid prototyping, where you can either quickly change a file and re-execute it without having to recompile and relink it, or alternatively, even as the program is running, you can quickly change the value of something. As an example, in a graphical user interface, I might be working with a customer. I might want to try different labels for a button, different text strings, different icons. I could quickly assign different icons and different text strings to that button to see what the customer thinks. And because I'm using dynamic typing, I'm able to have that label alternate between icons and text strings, and it can handle that without having to shut down my system, change the type of the variable, say from a text string to an icon, and then reload it. So I have much faster prototyping with an interpreted language. So those are our important characteristics of scripting languages that set them apart from compiled languages and which makes them easier to use. As we go through our scripting languages, you'll see for each of them how these factors come into play.